Hello everyone, I'm Hannah Shamloo. I'm an assistant professor here at Central Washington University alongside my graduate student here, Hailey Finch. So Finch is doing a master's project with me on the goat rocks, and her objective is to take these whole rocks that we've collected from the field. You guys saw us in the field a little bit this summer, or past summer, and she is trying to crush it to a very small mineral, zircon. So her goal in this lab is separating zircon from a whole rock. So she's going to walk us through how she does that.
Yeah.
Cool.
Do we want to go start with the big rock over here?
We can follow
Finch.
Just where I've put it in the lab.
Finch is in charge today, and I like it that way.
So we start off, like Hannah said, with something, big old rock. You go out, you collect a rock. This is a tuff from the Ohanapakash Formation. And the rock itself can tell us a lot, but what I'm looking for is tiny little zircons that hopefully will be in here. Not every sample is guaranteed to have zircons.
True.
So we have something like this, and we crush it down very fine to less than 355 micrometers. This is a different sample, but you crush it down and then you sieve it to this size fraction. And you can see here it's about a kilogram of material. And then once we get there...
So you did the crushing? Did
Yes,
you? So that's what you were doing this fall, that you were
Yes.
in there with your probably headphones on to protect your ears and to crush and crush and crush. So you took samples like that and got them down to this powder?
Yep. So you crush and then you sieve it down. So I did about 18 samples for crushing, and then now I'm going to be doing the next step, which is zircon concentration, because we don't want all of this. We want the zircons out of this.
Yeah.
So I'm going to be doing 11 of those. I've done 6 already.
But can I brag for Finch for a second? Because she's so wonderfully humble. So we have, how many of whole rocks did we start with?
We have like 50 samples.
We have like 50 samples. Finch has, I would say you've gotten to this size fraction
20 samples.
for 20
Yes.
samples.
That's a lot of work.
Okay, that's non-trivial amount of work that Finch has already done. And what she's going to show us next, she's already done 6 samples. So she's been very productive while she's been here. So I just need to brag for her because she's lovely and humble.
Just for context.
She's working her butt off. Go ahead.
you
Yeah,
very
of
much,
course.
What we end up, so this is one that I've gone all the way to just the final zircon concentration. You can kind of see in this
little
bag
envelope.
here, there's less than a gram of material.
You see it
So this
collected
isn't
here.
all zircons, but there should be zircons in here. So we start off with a kilogram, and we're hoping to get about a gram. So to get from there,
Pretty much. Okay, this is serious stuff.
So what minerals are in this bag, Hannah, just off the top of your head, and Hannah, or either of you? Like,
Sure.
it's only just a little bit of zircon. So what makes
Yeah.
up the majority of this sand?
Well, it depends. So
This
what
is
is
devil's
this?
horns.
Devil's horns. So yeah, what would we expect in devil's horns?
well, I know that it's an ash. There will probably be a lot of non-minerals, so glassy material
Yes.
like ash. So that eventually turns to dust. There will be likely some quartz, some feldspars, a lot of magnetic material, surprisingly, too. So micas sometimes, depends on the sample. Yeah, if you see some of these samples, you see how dark they are? It started off this light color, but when you do the zircon concentrator, you can see this is post-concentrator, you get kind of a dark color, and we eventually do take that out with a magnetic separator, but there's a lot of magnetic material in there too.
Yeah.
Yeah.
Thank you. Okay.
All right,
great.
so
we're down to the powder.
we have our bag, and then we take it over to this beautiful zircon concentrator developed by Dr. Chris Mattinson and some of his colleagues. He said he started developing the idea back when he was a grad student, but this whole machine is really, really ingenious. Zircon's a really dense mineral, so you kind of treat it like gold in a way where it gets stuck in the grooves. If you've ever done gold panning or anything like that, you agitate the whole sample and the light stuff flows away. So with this, I'm already about halfway done with a sample. I was hoping to have some zircons for you guys, but you dump it into our bucket here, and you mix it with some water, and we have this agitator here. It's just like a paint agitator, and you spin it with the water, and you have the water running. Once it flows up a bit, the sample will run over the table. Again, there's not much sample left in here, so it'll be pretty clear. Once we have that going, you also want the table, this is just extra water, to be vibrating because we want the sample to get stuck in each of these grooves. There's, I think, 10 grooves here, and ideally the heaviest stuff falls in the very first one. So to make sure all the sample is still running smoothly across the table, we have it vibrating, which is quite loud. And there's a couple intermediary steps where when you have it initially, it's really light, and there's a lot of small size fractions, and that can gum up the grooves. So we have intermediary steps where we vacuum out all that dust so that the heavy material doesn't just jump over the grooves. And then we eventually repipette it. So we have this right here, which seems like a lot's going on. It's just a vacuum. This is the air compressor, and the tubes just keep the vacuum going. And this is like, so that's the air compressor. This is like your nozzle of the vacuum. So you can see I already have some sample in there. This is right before the last stage. So there is zircons in here, ideally. And so the next step for me is to use a little single-use pipette because you don't want any cross-contamination. You could see with how tiny those samples were. Zircon's itty-bitty, especially in these samples.
Right.
So it's so small, it's easy to get contamination between samples. So that's something we really have to be careful about. That's why they're single-use. Yeah, so hopefully in the next hour, I will finish processing this sample and have zircons.
Cool. Can you give us a little preview of you sucking up the material from there? Oh, thank you.
You turn on the vacuum.
Okay.
Who trained you to do this?
Dr. Chris Mattinson, he's wonderful.
We're all fans of Chris.
And there's a little bit of material still in here. There's a couple grains that it hadn't quite run through yet. That's leftovers in here. And those should be the dense guys. And you use your vacuum tube.
Yeah.
And you scoop up the little bits through each individual groove to make sure you get everything. I've already cleaned this out pretty nicely.
Yeah.
Yeah.
And so then what's collecting down here?
That's our lights, so
Okay.
that's where the dusty leftover bits go. And we do have sediment traps in this system, but try and keep stuff, thank you, from going down.
So presumably, go ahead.
If I mess up or I accidentally let some zircons through, I still have this sample.
Yeah.
And if in the future somebody's interested in the lighter materials like the feldspars or the glasses, or they want to do more bulk rock stuff, this material isn't gone.
Totally.
We still have it. And if you get rid of it, it's gone forever. So it's just another thing to keep hold of.
Perfect.
Yeah.
So you got your little vacuum.
Got my little vacuum.
And then after this stage, obviously it's underwater. So what happens next to get that stuff out of there?
This vacuum is off. I carefully open it up. And the next step is to just put it back over the table.
Oh, okay.
I'm gonna turn off the water. And we have this handy dandy guide so I can check to see how much water I want running through the table. And right now for this last repipetting stage, I don't want the stirrer going, I don't want the first faucet going, but I want the second faucet at 17 GPH. So I'm going to go back over. I'm going to grab my things. Sorry, everyone.
No, do it.
This one's already running, and I want it at 17.
Okay, so you have a little gauge over here.
And you measure from the top of the float. So that's at 17.
Okay. So that's setting some sort of flow rate?
That sets the flow rate of the double jointed faucet right here.
Great.
We have two faucets running, one to go into the bucket during the initial stages, and then now for this end stage. Let's turn that off. So I'm gonna get rid of a little bit of the water here.
Okay.
But you just, you agitate it so that you can get the bits. Oh, I need this running. And you just do this until it's gone.
Makes me wonder what Mike Eddy does in the Purdue lab. Like they're doing zircons. This is
Same question.
Chris's
Yeah.
creation.
So
like,
cool.
What is the standard?
Not what I was trained on. My
What were you trained on?
similar, all the theory and concepts are similar. I used a very large water table, so like imagine this little water table with the grooves and the ridges, only on a broader scale. And then after this, we use heavy liquids. So that's using literally what it sounds like. It's methyl iodide. I might be saying that wrong, but it's a high density liquid. And so you put your material in it and your zircon will be separated because of the density of the liquid. Very toxic though. So it's dangerous. So this bypasses all of that. So it's actually really, I don't know, it's great for training students and it's just great for the user. So yeah, I'd be curious to know what Mike does too. Everyone does it a little different. The point is get the zircons out. So whatever works, but
All the effort to get these.
oh my God, I know. But what's exciting, and I love how Finch described this to us, all the stuff that's being caught there, a future student's going to work on that stuff. Finch has enough to do, right? We want to get her out of here at an appropriate timeline. But I do want a student to look at those quartz and feldspar because there's still so much to be learned from the other minerals too. We're starting with zircon for her specific objectives, but all this work she's doing will pay off for multiple generations. So we appreciate her.
Before we go back to Finch, what might those future students get out of working with quartz?
So zircon has a very specific saturation. It hangs around at specific temperatures and zircon saturation. So the conditions have to be just right to crystallize zircon. Feldspar and quartz might be recording different processes than a zircon. So looking at multi-phases in a single unit is really robust for really parsing out what's happening in the magma prior to eruption.
We're still talking about.
We're still talking. So yeah, are you doing Ohana Prakash right here? But the sample you guys were looking at was Devil's Horns rhyolite. And so what we want to know is what's happening in that magma chamber prior to eruption. Zircon's going to give you a long integrated window of record, where maybe feldspar and quartz are recording maybe the final things. But it's all important information. It's just what part of the story are you interested in? And right now we want to know the Zircon story first. It's a good place to start, especially for the questions she's trying to answer.
You realize I'm twice your age. When I was in grad school, we never talked about zircon. There was no discussion. There was no lab. There was no effort. It was all like potassium, argon, dating.
Sure, also important, but yeah.
But I mean, so that was also work. But this zircon thing is just a game changer.
It's so cool.
You're still.
I feel lucky that we have this equipment in-house. Thank you, Chris Mattinson. I mean, him and I think his student Gabe are the ones who built this.
And Trevor, I believe, is one of the ones
Okay.
who developed it. His colleague from back in his grad studies.
Okay, nice shout out to Trevor. Yeah, that's great.
Hailey, last quarter and fall quarter, you were down crushing, and now you're like done crushing, and now you're basically spending a lot of time up here.
Well, there's lots of samples I could crush. There's always more data that could, like, if I could do
That's a
everything I
t-shirt.
could. If I could do every sample we collected out in the field,
Oh my
and
gosh.
it wouldn't take forever. I would love to have that.
It'd be a PhD
full
at that point.
story. Yeah, but you got to be a little more realistic than that.
Yes.
And when crushing a sample takes a few hours, and every sample from like setup to tear down takes about 4.5 hours. So
Good to know.
you got to be a bit more realistic with what can I feasibly accomplish in the timeline before I need to collect my data.
Totally.
And so we're going to be collecting data like SEM. So we have a scanning electron microscope here at Central Washington, which is amazing. Again,
Just
Zircon
across the
lab.
hall. Yeah, just across the hall.
So I'll be using that later this quarter, early next quarter, and then collecting element data on the zircons, like Hannah was saying. Those small stories that these zircons can tell. All right, I'm done with the repipetting, so
Okay.
you can see the sample is
So
differentiated already,
Yes.
and the densest stuff concentrates in these middle layers, and it tends to be darker in this situation because a lot of those metals or magnetic particles are denser, so like iron rich, magnesium rich, and zircons. So there should be zircons in here.
Very cool.
I'm gonna turn off the vibration now, even though it should run a little longer.
So Hanapakash, I kind of want everything to be green. I mean, I'm just
Good point.
I know, right?
It's true.
One of the cool things about zircon is that it fluoresces under shortwave UV. So I haven't checked the sample yet.
Hailey, you're good on camera. God,
She's an athlete.
you are poised.
We only have 2 of these glasses, but shortwave UV, okay,
No, I'm kidding.
does not matter. Shortwave UV can make your eyes tired. So what I'm going to be doing is turning off this light, and I'm going to be pointing this at those high up grooves.
Love it.
To see if we see anything fluorescing. We'll see.
Sir. I know, isn't it fun?
Yeah, so right up here in the
okay.
top,
Yeah, I see
there's
it.
some really bright yellow
Get
fluorescing.
closer if you need.
Oh. Absolutely. This is dying a bit,
Oh,
but
batteries at CWU. Fail.
Fail.
oh.
You had some yellows.
Yes, and I can.
You want me to turn the other lights off?
Sure, yeah, that should help. Thank you, Hannah.
Uh-huh.
All right, we're gonna try one more time. They're really small, so
Tiny, tiny.
you'll see a red background, and that's the magnetic material.
I see.
And then the bright yellow stuff sitting on top, that's the zircons.
Put my camera to the test. I think we're getting there.
Okay.
So you're showing us that there's just, that's another check for Zircon, or are you talking
Yes.
about something totally different?
Nah, this is just another check to say, yes, we have, ooh, there's a nice concentration here. Wow, look
hello.
at those.
Hello.
Hello. Good morning.
Yeah,
Oh, that is a nice cluster.
and they're just so pretty. And
Very cool.
Chris was saying that this was a new discovery for him. All right, light back on.
Yeah, okay.
Um,
Done with
a new
these.
discovery for him. It's a great way to be able to track the zircon, and you know, if you're not having zircon in a sample, why continue processing it all the way through to the picking stage? So this is a confirmation for sure that we have zircon. So, woo!
Love it. Yay. Okay.
Yeah.
Very
I'm
exciting.
going to turn the water down here. So the next steps for this is to further get rid of some of this bulk material, and I'll do that by changing the angle and the vibration of the table.
Okay.
And then eventually use the vacuum one last time and get the zircons out.
Okay. And then would you dump the water, your final stage, dump the water and then dry it under a heat lamp, or do you just let it air dry?
I'll dump off most of the water, and then
Okay.
this is just tap water, so it has minerals in it.
Oh,
and
yes.
so I will rinse it with deionized water, which there's a tap for in this lab, which is great. I'll rinse that a couple times, and then I'll just put it in the oven for
Okay.
about a day.
Great.
Let it evaporate out, and then I'll put it in a baggie for the next steps.
Yeah, so Finch isn't done after this. There's a whole nother set of steps, which you are now trained on Franz?
Yes.
Good.
As of yesterday, I'm
Okay,
trained
cool.
on Franz, which
Yeah,
is also
so-
in this lab.
There's another step to remove the magnetics, which is still in this lab if you want to see it.
Yeah.
Okay.
All right.
You want to talk about that?
Sure.
I'll turn the
Um,
lights back on.
So like we saw in those other samples of the heavies that I've already zircon separated, there's still a lot of magnetic material. And so what we use is a Franz, and this is a big electromagnet that you can change the amperage, which is what we do. This is deconstructed right now because, again, you don't want cross-contamination from dust or anything, so we keep all the bits in the drawer. But the idea is similar to the Zircon concentrator, kind of. It uses vibration to send all the grains, you have the grains here, and it'll shoot it down a track that's, again, not set up right now.
Right.
And then this is a big magnet, so all the magnetic material will get stuck to this, while all the zircons and non-magnetic material go down into a collection that we'd have at the end. And then that tiny little packet I showed you at the beginning, that's the end result, which I will get trained on in the future, but I need to learn how to pick zircons and then mount them in epoxy.
So you're going to have tiny little packets for each of your units that potentially
11
went
samples.
into those magmas.
Yeah.
And that's
Hopefully.
after all this process, right? And Hannah, how does that fit into your overall project? If, or both of you, like, this is a tephra only project. It's not, or it is?
So, well, I could let Finch answer too. The volcanics Finch is looking at from Goat Rocks are, there's a dacite lava, and there's then Devil's Horns rhyolite, which is a big tephra. So it's not just tephra, it's silicic. So she's starting her project focusing on the silicic volcanism at Goat Rocks. But there's, of course, a ton of intermediate and mafic stuff. We don't have time to get to that.
And also zircons generally aren't in the mafic
Yes.
aspects, so that's one of the reasons why we chose to focus on the silicic.
Totally.
So we know for sure, or not for sure, we have a better likelihood of getting zircons out of these samples.
Yeah, that's a great point. Yeah, mafic material's not going to, again, that zircon saturation, zircon's not going to be stable in these mafic materials. So it's not going to form.
So Finch might be out the door in 1.5 years, and you're going to have another batch of grad students who continue with the Goat Rock?
Oh, yes. Oh, yes. This is a 4-year project.
And undergrads.
And undergrads, yeah, exactly. And undergrads. There's a lot to be done just on Devil's Horns. And that's 1 unit out of many at the Goat Rocks, so.
Thank you. Anything else?
I don't think so.
Good job.
Yeah,
Thank
Finch
you.
slays.
Look at this view.
Thanks, you too.
Okay.
I'm just saying.
Okay. Okay, here we go.
At least in my undergrad.
Wait, yeah, that's true.
You don't get a view like this.
She's
when you're
right.
Processing for MinSep.
Yeah, actually, Finch and I were just bonding over the fact that we were trained in labs in a basement, which is how most people are trained. So the fact at CWU we have these windows is pretty awesome.
Get some afternoon sunlight.
Yeah, it keeps the spirit going. Keeps the spirit going.
Tower.
Oh, yeah, exactly.
Thank you both.
Thanks,
Thank you,
Nick.
Nick.